Welcome to another Python programming tutorial. Today, we're diving into one of the most fundamental concepts in Python, if statements. If you've ever wondered how to make your programs respond to different conditions, you're in the right place. We'll cover everything from simple conditional checks to advanced techniques, like using if statements with lists and styling your code for maximum clarity. Stick around because by the end of this tutorial, you'll be able to write smarter, more dynamic Python programs that handle decision-making like a pro. Let's get started. If statements let your program respond intelligently based on conditions, for instance, checking if someone is eligible to vote. This code is a simple example of an if statement, which allows the program to make a decision based on a condition. In this code, the variable age is assigned the value 18. The if statement checks whether the value of age is greater than or equal to 18 using the greater than or equal to operator. If the condition evaluates to true, the indented block of code immediately following the if statement is executed. In this case, the program prints the message, "You are eligible to vote." Since age is exactly 18, the condition is satisfied and the message is displayed. If age had been less than 18, the condition would evaluate to false and nothing would be printed because there's no else statement in this example. Python supports various ways to test conditions, including equality, case insensitivity, and numerical comparisons. Each of these checks helps refine logic. This code demonstrates a conditional test for equality using the double equal sign operator. The variable car is assigned the value BMW. The first print statement checks if the value of car is equal to BMW's, which evaluates to true, so true is printed. In the second print statement, the code checks if car is equal to Audi. Since the value of car is BMW, this condition evaluates to false, and false is printed. These checks are case-sensitive, meaning BMW with capital letters and BMW with small letters would not be considered equal. Here, the lower method is applied to the string stored in car, converting BMW with capital letters to BMW with small letters. The double equal sign operator then compares the lowercase version of car with the string BMW, and since they match, the condition evaluates to true. This is a common technique for performing case-insensitive comparisons in Python. This example shows a numerical comparison using the greater than operator. The variable number is set to 10, and the condition checks whether number is greater than 5. Since 10 is indeed greater than 5, the condition evaluates to true, and true is printed to the console. Python supports various numerical comparison operators such as less than, or equal to, greater than, or equal to, and double equal sign. You can combine conditions using and, or, and check for membership with in. These help create more powerful conditional logic. This code demonstrates logical operators. The first condition uses the and operator, which ensures both conditions, age is greater than 18 and age less than 30, must be true for the whole expression to evaluate as true. Since 25 is greater than 18 and less than 30, the output is true. The second condition uses the or operator, which requires only one condition, age greater than 30 or age less than 20, to be true. Since neither condition is true for 25, the output is false. This code checks if the value banana is present in the list fruits. The in operator returns true if the value exists in the list and false otherwise. Since banana is part of the list, apple, banana, cherry. The output is true. Use if-elif-else for multiple conditions, ensuring Python evaluates them in sequence. This is a simple if statement that checks if the temperature is greater than 25. The variable temperature is set to 30, which satisfies the condition temperature is greater than 25. Therefore, the print statement inside the if block is executed, and the output is "it's hot outside." This code adds an else block to handle situations where the condition temperature greater than 25 is not met. In this case, since temperature is still 30, the condition evaluates to true, and the first print statement runs, "it's hot outside." If temperature were 25 or lower, the condition would evaluate to false, and the else block would execute, printing, "it's not too hot." This example introduces an if-elif-else chain to check multiple conditions in sequence. The first condition, temperature greater than 25, is evaluated. Since temperature is 15, this condition is false, and the program moves to the next condition. The elif block checks if temperature greater than 15. Since temperature is equal to 15, this condition is also false, so the program moves to the else block. The else block executes because none of the previous conditions were true. It prints, "it's cold." If temperature were between 16 and 25, the elif block would execute, printing, "it's warm." Similarly, if temperature were above 25, the first if block would execute, printing, "it's hot outside." If statements become even more powerful when used with lists, enabling dynamic interactions based on content. This code checks whether mushrooms is an item in the list requested toppings. The in operator returns true if the specified element exists in the list. Since mushrooms is indeed in the list, mushrooms, pepperoni, extra cheese, the condition is satisfied, and the print statement inside the if block is executed. The output is adding mushrooms. If mushrooms were not in the list, the condition would evaluate to false, and nothing would be printed. Here, the list toppings is empty. In Python, an empty list evaluates to false, and a non-empty list evaluates to true. The if block checks whether the list toppings has any elements. Since it is empty, the condition evaluates to false, and the else block executes, printing, "no toppings selected." If the list had elements, e.g. toppings equals to pepperoni mushrooms, the condition would evaluate to true, and the print statement in the if block would run instead, printing, "toppings selected." Writing clean and readable if statements is crucial. Follow best practices like consistent indentation and simplifying logic. Let's take a look at this example. Python requires consistent indentation to define code blocks. Here, the print statements under both the if and else conditions are indented with 4 spaces, making the code clean and readable. This is crucial for maintaining clarity and avoiding syntax errors. The conditional statement age greater than or equal to 18 has a space on either side of the comparison operator. This follows Python's style guide, PP8, which recommends adding spaces around operators for better readability. The condition age greater than or equal to 18 is straightforward and easy to understand. Avoiding overly complex or nested conditions improves readability and maintainability. Both print statements are concise and directly communicate the outcome of the condition. This aligns with the principle of writing clear and self-explanatory code. There is no redundant logic or extra variables in the code. Keeping it minimal ensures that the focus remains on the if-else logic. Both the if and else blocks follow the same formatting style, making the code visually balanced and easy to follow. Always include a space after the if and else keywords and before the colon. Avoid overly complex conditions by breaking them into smaller, well-named functions if necessary. Ensure consistency in indentation and spacing throughout your code. Use comments sparingly to explain the purpose of conditions if they are not self-explanatory. This code is a good example of well-styled Python, adhering to PEP 8 standards for clarity and readability. Congratulations on mastering if statements. Thanks for watching. If you enjoyed this tutorial, hit that subscribe button and join me for more Python programming adventures.